Welcome back. Let's do question 2. If f of x is equal to x plus 2 times x minus 4 times x minus 4, then find the coordinates of the y-intercept of the graph of f. 1 mark. This should be easy. How do we find the y-intercept? How do we find the coordinates of the y-intercept? Where there's x, we put 0. So it means y is equal to, remember, y is f of x. This is f of x is equal to 0 plus 2, then 0 minus 4, and then 0 minus 4. Right, negative 4 times negative 4, that is positive 16, times 2, that is 32. So it means y is equal to 32. Therefore, the coordinates of the y-intercept are 0, 32. Okay, then you get your mark there. Let's do B. We're given f of x is equal to x plus 2 times x minus 4 times x minus 4. Determine the derivative of f of x. Remember, for us to be able to derive, our terms in the equation should be in the form a times x to the power n, like that. And then we can say n times a, and then x to the power n minus 1. We can use this rule to derive. So we have to expand this and remove the brackets, isn't it? So we may do this differently. Someone may start by expanding these two, or someone may start by expanding these two. But I'll prefer to start with these two, x minus 4 times x minus 4. So we have x plus 2. Let me put a square bracket here. So I have x minus 4 times x minus 4 inside the square bracket. Then f of x is equal to x plus 2. And then let's expand this. This is x squared, and then 2 times x times 4. Then because of the negative 4, there's going to be negative 8x. And then we square negative 4. Negative 4 squared is positive 16. Right, that's a shorter way of doing it. Remember, you can do it using your FOIL method. X minus 4, x minus 4, x times x squared, x times negative 4, negative 4x, negative 4 times x, negative 4x, negative 4 times negative 4 is positive 16. Then we have x squared minus 8x plus 16, isn't it? Let's expand. Let's multiply the binomial and the trinomial. So we're going to multiply everything in the second bracket by x. It becomes f of x is equal to x cubed minus 8x squared plus 16x. Then we multiply everything by 2. So it's going to be plus 2x squared minus 16x, then plus 32. Positive 16x minus 16x is 0. We remain with f of x is equal to x cubed, then negative 8x squared plus 2x squared, that is negative 6x squared, and then plus 32 like that. Right, now we have our terms like this. We can now derive using the rules of differentiation. Now just derive this. 3 times 1, that is 3, and then x to the power 3 minus 1, that is 2. We have derived x cubed. Remember, every term is derived independently. Right, 2 times negative 6, that is negative 12. Then x to the power 2 minus 1, that is x to the power 1. 2 minus 1 is 1, so we remain with x to the power 1. The derivative of a constant is 0. So this is the derivative of f of x. Now, for what values of x will the derivative be equal to 0? We just managed to get our derivative. We said that our derivative is equal to 3x squared minus 12x, isn't it? Right? Now, we're saying this derivative is equal to 0. 3x squared minus 12x is equal to 0. How can we solve this? By factorization, by completing the square by the quadratic formula. I think factorization is easier because we have the highest common factor, which is what? Which is 3x. So we can factor out 3x here. Then 3x squared divided by 3x, that is x. Negative 12x divided by 3x, that is negative 4. Then it's equal to 0. So it's either 3x is equal to 0 or x minus 4 is equal to 0. So x is equal to 0 or x is equal to 4. If you check, these are actually the x coordinates of the turning points. Okay, remember to find the turning points of the cubic graph, we derive and equate the derivative to 0. Then we'll get the x coordinates of the turning points. Remember that. Now, for the same function, when the set of x is provided, sketch the graph of f. Right, remember we have the following from question 1, from A. We found that the y-intercept, the coordinates of the y-intercept are 0, 32, right? And then from C, we found that the derivative is equal to 3x squared minus 12x, and then we equated this to 0, and then we solved and found that x is equal to 0 or x is equal to 4. These are actually the turning points of what? Of the cubic graph. Right. If you check, when x is equal to 0, what is y? When x is equal to 0, y is equal to 32. So meaning that this point, it is a turning point and a y-intercept. Or what you could have done, you could have substituted 0 here where there's x, and then you're going to get 32. Right, we have the value of y when x is equal to 4. We actually have, if you check here, x is equal to 4 or x is equal to 4, and then also we have x is equal to negative 2, right? These are the x-intercepts. At the same time, when x is equal to 4, it means that's where the turning point is, meaning that at x is equal to 4, that's where you have the other turning point. All right, or you could have just substituted 4 here where there's x, and then you're going to get 0. Okay, you get 0. 4 plus 2, that is 8, and then but 4 minus 4 is 0. 4 minus 4 is 0. 0 times 8 is 0. So meaning that this is another turning point. So we have turning points at 0, 32, and also at 4, 0. From this is enough. If you have two factors that are the same like this, it means this is where the turning point is, right? What do we need? We need the point of inflection. Point of inflection. Point of inflection, we have to derive the derivative. So we say second derivative, we're deriving 3x squared minus 12x. So we're deriving this 2 times 3, that is 6, then x to the power 2 minus 1, that is 1. There's a 1 here, so we're saying 1 times negative 12, that is negative 12. Then x to the power 1 minus 1 is 0, so x to the power 0 is 1. It disappears. This is the second derivative. And then we equate this to 0 to find our x coordinate of the point of inflection. And then we say 6x is equal to 12, and then x is equal to 2. It means the point of inflection is that x is equal to 2. And then what do we do? Where there's x, we put 2 to find the y coordinate. So y is equal to, we're substituting the x value into the original equation. So y is equal to 2 plus 2, and then 2 minus 4, and 2 minus 4. This is like 4 times negative 2, which is negative 8. Negative 8 times negative 2, which is positive 16. So the point of inflection will be 2, 16. So now we have our intercepts, turning points, and the point of inflection. We find that our equation was f of x is equal to x cubed minus 6x squared plus 32. That was in question B. And then our a value is positive. Remember that if the a value is positive, our graph will be like this. The last part is pointing upwards. Okay, if the a value is positive, the last part will be pointing upwards. Then if the a value is negative, the last part will be pointing downwards like this. So it means this is the shape we're looking for. Right, let's plot the points. We have negative 2, we have 4, and then we have 0, 32, 30, 32 should be here. They say this is negative 2, 0. Indicate the points, indicate the critical points. Then this is 0, 32, then this is 4, 0. Right, point of inflation is at 2, 16, so it should be somewhere here. That is 2, 16 point of inflation. Then what else do we need? I think we have our shape. This should be our graph. This should be our graph like this. This is the turning point. And then we can sketch a graph nicely. Okay, indicate the intercepts, turning points, and points of inflection. Now let's go to E. Right, E says, for what values of x will the graph f of x be greater than or equal to 0? What is the meaning of this? Greater than or equal to 0 means that the graph is above the x-axis. So where is the graph above or on the x-axis? Because it says greater than or equal to. So it should be on the x-axis or above. So all this part, the graph is above. The graph is above. That's what we want. So for which x values? You see, that's where things change here. At x is equal to negative 2. When you go this side, you find that the graph is below the x-axis. But if you go this side, the graph is above or on the x-axis. So this region we want, where x is greater than or equal to negative 2. Okay? But when x is less than or equal to negative 2, that's what we don't want. Less than or equal to negative 2, we don't want this. We want where x is greater than or equal to negative 2. So that's the solution there. For which values of x is f of x above the x-axis when x is greater than or equal to negative 2.